Alright, so we're moving on to week 3. Week 3 of our distance learning is going to be over data analysis and regression. So in most of these problems, you're going to get a table. And then from this table, we're going to ask you to make a scatter plot and find something called a regression equation, which is, you'll also hear me use the phrase line of best fit. It's not always a line, so maybe I should say model of best fit. But we're going to find a parent function that matches the graph as best we can. It's not going to be perfect, but it's which type of function best supports the data. So before I get into more examples, I want to talk about what do the parent functions look like for those of us that don't remember. Hopefully exponential you remember, since we just spent basically 2 weeks on it. But with an exponential function, we've got a couple things to note. There's 2 different types of exponential growth and exponential decay. Doesn't really matter that much, that terminology with regression. But what I'm looking at with exponential is it starts off pretty flat right here, and then it increases rapidly as we go. Exponential decay is kind of the opposite. It starts decreasing rapidly and then tapers off. So when you're looking at a scatter plot, if it has a flat piece and then it increases fast, or if it's decreasing really fast and then tapers off, that's going to be our cue in our mind to say, hey, this scatter plot's probably some form of exponential model. What I do want to note with exponential also is we need to note the range, which is why I have that in giant red font for you. So an exponential model, if we remember from 2 weeks ago, exponential has a horizontal asymptote. The horizontal asymptote for most of our models is going to be 0. So if we give you a table or a data set that has negative y values, so if it has negative values in the range, then we know our model can't be exponential. An exponential model has an asymptote at 0 unless stated otherwise. So if you have negative y values in your range, exponential regression will not work. You may or may not want to make a mental or physical note of that for the assignment. Alright, we should know what linear and quadratic look like by now. But if you have data that looks like a pretty straight line, again, we're not going to see perfect stuff. So you're not going to get something that looks like a perfect line. But if it looks similar to a line, we're going to say that's linear. And then quadratic, it should be a U-ish. So it should go down, reach a bottom or a minimum, and then go back up. And quadratic could also be the other way. It could also look like this, where it goes up, reaches a maximum, and then comes back down. Alright, so those are the big 3 we're going to talk about, is exponential, linear, and quadratic. So let's go look at some scatter plots. And a scatter plot is a graph, but the dots are not connected. So this is real world data. So it's not going to be connected because the first one, we're talking about how many whooping cranes are in the state of Texas since 1940. Well, they took the population every 10 years. So I don't know how many whooping cranes there were in 1943 in June, because I didn't survey the whooping cranes then. I just did it every 10 years. So I'm not going to connect the dots here because I don't know what's in the middle, but I do know these discrete points. Alright, so the first one, I know I just said we're not connecting the dots because we're not, but to help me choose the model, I'm going to connect the dots in my head. But since I have this in front of me, I'm going to go ahead and physically do it. So if I connect the dots like that, I'm trying to figure out, does this look like a straight line? And hopefully you can see that and say, absolutely not. That's definitely not a straight line. Then I'll go to, is it quadratic? Well, a quadratic should come down, reach a minimum, and then go back up to form a U or an N if it's upside down. I don't see that either. I do see a flat-ish part that then increases rapidly as we go. So that is going to be an exponential model, because it starts off flat and then it increases rapidly as we go. Okay, so now the middle one. So the middle one, that's about as perfectly as a straight line as we can get with data analysis. So if I connect the dots in my head, that looks like a pretty good straight line. So that's going to be linear. And then this one, if we kind of connect the dots, oops, I didn't mean to delete that. If we kind of connect the dots, that looks like a pretty good U to me. So that is going to be quadratic. So on a lot of these questions, it's going to ask you which parent function matches. And then based off that, it's going to ask you to do something called a regression equation, which I've got my calculator pulled up on my other screen. My calculator is going to be a little blurry, but it is what it is. If y'all need help, we can go through it on Zoom if necessary. Okay, so here's my first example. It says the table below shows the total attendance at Major League Baseball games in the years since 1930. So this, the X variable is years since 1930. I left off 1930 on accident. And the Y value is how many people attended the games, but in millions. Obviously, there wasn't 8 people at the game, so it's in millions. But we can leave it with smaller numbers. So it says years since 1930. So when you see this year 0, that stands for 1930 because 0 years have happened. 10 years means it's 1940. 20 years means it's 1950. You can use those big numbers like 1930, 1940, 1950, but it's going to make your regression kind of weird because the X values are so large. So a lot of times with time, we like to do years since just to keep our time small. Okay, so the first thing it asked me to do is make a scatter plot. Now, if we were in class on a worksheet, we'd be doing this in our calculator or transferring it to a sheet of paper. So when you get to Moodle, you're going to see this little drag and drop feature. You're just going to drop the little dots into the little rectangles where they go. So there's going to be a black dot at the bottom, and there's going to be an unlimited amount for you, and you're going to drag that little black dot into the points on the scatter plot where they go. Obviously, you're not looking at the assignment right now, but hopefully that makes sense when you see it. Because normally we don't have you graph on Moodle, but here we are. Okay, so we make a scatter plot. And I did this on my calculator ahead of time, just for video's sake. I already talked slow enough. So if we plotted these on a piece of paper, or plotted these in the calculator, we'd get a plot that looks like this. And just like my last slide, we're going to figure out which model fits best. So again, this is a discrete function, so the dots are not connected. But if I did connect the dots, it would look like that. And just like my last slide, I noticed that it starts off flat, and then it's increasing rapidly as I go. So I am going to say that this looks pretty exponential to me. Okay, so now number 3. So here's some new information. We're going to do something called a regression equation, which basically creates the equation of this fake line that I drew. So that exponential curve that I drew with my marker isn't really there because it doesn't perfectly match the points. You can see that I didn't cover up all the points, but it does a pretty good job of estimating the scatter plot. So how do we find a regression equation? So that's what we need our calculator for. So my writing is going to go away for a second, but I'll put it back. So, to do our regression equation, we're going to have to hit a series of buttons. So, if you have your calculator that they programmed on your Chromebook, it should look something like this. Or if you're using your home calculator, it'll definitely look like this. You have a TI. So stat, we're going to hit the stat button. It's right at the very top. And then we're going to edit. Anytime you're typing something into the stat command, you're going to go to edit. So you're going to hit the stat button, then go to edit. And then you're going to type in the data. So this is the data from my last screen. It's just the table. It doesn't come pre-programmed. I typed it in to save time. So I put the year since variable here in the X column, and I put the attendance variable in the Y column. And I just typed it in. So here's how we actually do. So we're going to go to stat, edit, and then we're going to type it in. Then we're going to go to stat, calc, or calculate. And then there's some things right here. There's linear regression. So if we thought that linear was the best model, we would pick number 4. If we thought quadratic was the best model, we'd pick number 5. If we thought exponential was the best model, which if you remember, I thought exponential was the best model. So since we thought exponential was the best model, we're going to pick expreg, which is exponential regression. And then it's going to pull up all this stuff. You don't need to change any of this. L1 is where I put the X values. L2 is where I put the Y values. It's just the list. You don't have to worry about frequency. You don't have to store it unless you want to. And then we're going to calculate it. So if we see, it says that my function is a b to the x. And then my a value is 7.72 and my b value is 1.03. So I'm going to go back to my PowerPoint and I'm going to write this equation down. But remember, this equation is not going to perfectly represent the data, but it's the best fit for the data. So it's not perfect to the curve, but it's the best estimation we can get. Okay, so now we're back to the PowerPoint. So if you see, if you remember from the calculator, I did my exponential regression, and I had the value 7.72 and 1.03. All I did was transfer that to the PowerPoint and put them into the spot in the equation they go. So the calculator tells me that the exponential equation is y equals a b to the x. It tells me that equation, and then it tells me a equals and b equals. So if you have exponential, you have this equation, and then it's going to tell you a and b. Just put them where they go. All right? So now the last question is, why do we care to do this, right? Why do we care to take data we already know and figure out an equation if we already know the data? Well, it allows us to predict the future or backtrack to the past if we wanted. So number 4 is why we care. So number 4 says, using the model we created in number 3, which is my equation, how many people will attend in the year 2020? And obviously, if you're a baseball fan, we don't have baseball right now because of the coronavirus, but assuming we were actually playing games right now, what could we assume for attendance? So my equation, and I'm sorry for the Doceri desktop trial. I don't know how to make that go away if you've never watched my videos before. So I have y equals 7.72 and then 1.03 to the x. So I just rewrote my equation, and it tells me in the year 2020. So my x variable is my time, but if we remember, it's years since 1930. So I'm not going to plug in 2020 for x. I'm going to plug in how many years after 1930 is the year 2020. So, for all you math majors, to get from 1930 to 2020, that's 90 years. So I'm going to type into my equation, or plug into my equation, my x value is going to be 90, because it's 90 years since 1930. And then I'm going to go back to my calculator. And when we go to the calculator and we plug this in, we see that my attendance will be about 110.4 million people. So again, this allows us to kind of predict the future. So number 4 asked me to predict how many people will attend baseball games in the year 2020. And because of the regression equation we found that 110.4 million people will attend MLB games in 2020. So this is all you're going to be expected to do. I'm going to do one more. I'm going to try to go much quicker because I know y'all are tired of hearing my voice. It's already at 15 minutes. But since I don't have you in class, I'd rather over-explain than under-explain. So, the second one, which this is the same one because it didn't switch slides. There we go. The second one is also baseball because I'm a baseball fan and I miss it. So, the table below shows the average distance a baseball travels based on the angle at which it leaves the bat. No, don't freak out. This has nothing to do with geometry, even though I use the word angle, so calm down. But I have a table again. My x value is going to be the angle, call it the launch angle, and my y value is going to be the distance that the ball travels. So again, if we make a scatter plot, and again for the second time on Moodle, there's going to be a little black dot at the bottom of the blank scatter plot. You're going to drag the little black dot to the points where it goes on the graph. It's pretty easy and pretty straightforward, but if you have questions on how the graphing feature on Moodle works, just shoot me or your teacher, if you're not my student, shoot them an email, and they'll go over with you. So we make a scatter plot, and it looks something like that. And we look at this scatter plot and say, well, that's definitely not a straight line, so linear's out. It does not start off flat and then increase rapidly. It does not decrease really fast and then taper out, so it's not exponential. So it says which model fits best. That looks like a pretty good U to me, even though it's upside down. So that looks pretty quadratic to me. So again, we make our scatter plot, and then we're determining is it linear, quadratic, or exponential. That's a pretty good U, even though it's upside down. So that's going to be quadratic. And then number 3 is going to be write the regression equation again. So writing the regression equation requires our calculator. So I'm going to switch screens. Okay, so again, for the questions that ask for the regression equation, we need our calculator. So we got to use the calculator pre-downloaded on our computer, or if you have your own computer, you can go to the TI website and download it, or if you have your own. Hopefully you've been using a calculator because this is week 3. But if you need help, don't be shy. Shoot us an email. We'll figure it out. So we go to Stat, Edit, because I'm trying to type in the table into my calculator. So when we're doing the regression equation, we hit the Stat button. Then we're going to edit because we got to type in the table. The calculator doesn't magically know what table we're using, so we have to tell it. So we go to Stat Edit, and again, it doesn't come pre-typed. Just the video is long enough. So you go to Stat Edit, you type your X values into list 1, L1. You type your Y values into list 2, or L2. So just transfer the table into your calculator. And then to actually find the equation itself, we go to Stat Calculate, so because we're calculating my regression equation. Again, if you think it's linear, you go to linreg. We didn't think it was linear. If you think it's quadratic, we go to quadratic regression. We did think it was quadratic, so I'm going to pick that one, and I'm just pressing Enter. When I say pick it, I mean press Enter. If you don't see my mouse, the Enter button's red, because that's what I'm clicking. And you can even see my key history down here. L1 and L2, you don't have to mess with any of these. We're going to scroll down to Calculate, press Enter. And then here's my quadratic regression. And again, these aren't perfect, so this isn't going to be 2x squared plus 4x plus 6. It's not going to be beautiful. But it is going to be a pretty good estimation that fits the data. So I'm going to switch back to my PowerPoint, and I'm going to transfer this equation that my calculator gave me back to my PowerPoint so we can actually answer number 4. but you go to quadratic regression, it gives you the parent function at the top, the ax squared plus bx plus c, and then it tells you a, b, c. So I'm just going to put those numbers where they should go. Alright, so again, I took the equation from the calculator, the regression equation from the calculator, and I transferred over to the PowerPoint so we can see it. So when you're doing your work, I would write it down on a piece of paper, that way you can just look at it. And again, the reason we care about this regression equation is that it allows us to predict the future without actually trying to hit a baseball at perfectly 75 degrees. We can just estimate what will happen if we do, based on this model that fits the data pretty well. So using the model we created in number 3, so my wonderful equation, how many feet would a baseball travel at an angle of 75 degrees? So I don't have 75 in my table. My smallest is 10, my biggest is 64. But based on the given data, I can estimate at 75 degrees. So I'm going to copy my regression equation down. But instead of x, I'm going to put 75 because it wants me to estimate the y value distance given the x value degrees. So I'm going to go to my regression equation, and I'm going to replace the x value with 75. So I replaced my x values with 75. Just type that into your handy dandy calculator, and it's going to equal 150.85 feet. So if we hit a ball at a launch angle of 75 degrees, it will travel about 150.85 feet. So I'm sorry for the extremely long video. I know it's 22 something minutes. But regression, so you're going to make a scatter plot or use the scatter plot given to you depending on how the question is set up. But you're going to make a scatter plot, choose which model fits it best. So is it linear, is it quadratic, or is it exponential? Don't overthink it. We're not trying to trick you. But is it linear, quadratic, or exponential? Then the new part is the regression equation. So to write the regression equation, you go to Stat, Edit, in the calculator, so stat, enter, type in the table, just copy the table exactly into the calculator, then you go to stat, scroll over to calculate, and then you're going to choose the regression equation that matches what you think the scatter plot is. If you have any questions, since this is pretty calculator command heavy, just email me, or I do a Zoom Monday at 1 p.m., so you probably already missed it if you're watching this video, unless you watched it on Sunday or Monday morning. But I can help you through email or remind one-on-one. Good luck.